to speak, is volume. We have 3 lessons left. We're all about how do we use integrals to find volume. Now, this first volume lesson is about cross sections. And so being able to take a shape and cut it into cross sections. Okay, so like a 3-dimensional shape, cut it into cross sections. In order to do this, we're going to have to kind of review some basic area. And in all honesty, I'll look at the area within each problem as well. But right here, it talks a little bit about area formulas and how we can think them through. So, as it mentions up here, it's volumes of 3-dimensional shapes where the cross sections are geometric shapes like squares, triangles, semicircles, rectangles, and such. Thus, what we're looking right here. I'll try and have a visual maybe tomorrow, but the idea is these 3-dimensional shapes cut into cross sections so that, you know, you might have a whole bunch of rectangle next to rectangle next to rectangle next to rectangle, or triangle next to triangle next to triangle. And so those are the pieces you have to be able to find the area of. And then by integrating that area, we are accumulating it into volume. So now, square. These are all based on the idea of if you know the base. Okay? So if you know the base of the square, how do we do area of a square? Base times base, or in other words, base squared. Okay? If you know on a rectangle, the base, and you know that the height of the rectangle is equivalent to 1/2 the length of the base, what's that area going to look like? 1/2 b squared, right? So the idea that it'd be the base times the 1/2 b, and so 1/2 b squared. And here's what's going to happen. We're not going to necessarily use these exactly, but on some of them we're going to use the ideas of them. Okay, semicircle. Okay, so we know pi r squared is a full circle. A semicircle is going to be pi r squared divided by 2, but what if we need to do this in terms of b?
That would be 1/4 because the b is the diameter.
Okay, so we're getting there. Okay, so the idea, if this is r, right? So what do we know? We know that r is equivalent to 1/2 the base, right? Or in other words, b over 2. And so, and you guys already talked about the idea of pi r squared divided by 2, right? So put this all into play. In other words, there's still going to be the, how do I want to write this? The pi over 2, right? That's the pi over 2 times the r squared. Well, what's r squared going to be? That's going to be b over 2 squared. Does that make sense how I did that? Maybe. The pi over 2 being this pi over 2 right here. And then it's times the r squared. Well, if r is 1/2 the base, it's going to be 1/2 the base times 1/2 the base. What does that look like if we put that all together? My key has it listed as pi over 8 times b squared. That could also be pi b squared over 8. Okay, this is how our brains have to work to think about some of these areas. Isosceles right triangle with base as a leg. And notice it does say isosceles. What's isosceles mean?
The 2 sides are equal.
Yeah, so if this is B, then this is also B because it said isosceles. So what's that looking like? Yeah. 1/2 b squared. Okay. Isosceles right triangle with hypotenuse as base.
So like rectangles and triangles, isosceles triangles, technically could be the same area if it has the same base. It's like cutting a square in half, but in a different one.
Yeah, here we're cutting the square. Here the key is, here the base was one of your 4 sides of the square if you're comparing it to square. Here it's a diagonal.
Yeah, I was just talking about like the first one is equal to the rectangle, so like they could be the same.
Oh yeah, it all depends on your dimensions. Oh, I see what you're saying, because that formula is the same. It's difference of what? And here it's because these two pieces are the same. So, okay, so on this one, first of all, if it's an isosceles right triangle, that makes these guys 45 degrees, if you will. Correct? And so if they are 45 degrees, and what do I want to think of this as? That whole piece is base. I want to go, I guess I would think of it if we split this. There's a couple different ways I could go here. Try and decide which is the better. If I split this into 2, these 2 are also going to be 45, 45, 90s, right? And if I do that, what does that make this bottom side right here? 1/2 the base, and then this is 1/2 the base, right? If this is 1/2 the base, what is this height here? Is it also, I mean, if we call it height here, it's also 1/2 the base, because that's going to match up as a side of a 45, 45, 90, correct? And so if we use all of that information to do the area, well, area of a triangle is what? Make that a little bit smaller. 1/2 times the length of the base. What is my entire length of the base? B, right? Times what did we come up with for the height? And that's going to be equivalent to 1/2 the base. So if we do 1/2 times base times 1/2 the base, we end up with 1/4 base squared. Okay. One more. We'll see if I can get in. Equilateral triangle. What do we know about equilateral triangle? All sides are the same. All angles are the same. Yes. It's a 60. That triangle is a 60, 60, 60. The key is going to be finding the height. Yes? And
Megan Connor, please report to Mr. Huntley's room. Megan Connor, please report to Mr. Huntley's room. Thank you.
okay. Go when the bell rings, if nothing else. Okay, 60, 60, 90, or 60, 60, 60, or breaking it into 30, 60, 90, yes? Do we remember our 30, 60, 90 rules?
No.
Oh, come on, dig deep here, right? So the idea that this short leg opposite the 30 is 1/2 b, right? The hypotenuse is 2 times b, or 2 times the short leg, which is just b, but wouldn't we already know that? And what's the height? What's that long leg? And it is square root of 3 times the short leg. So square root of 3 times 1/2 b, or in other words, square root of 3 over 2 times b. That would be your height. Yes, I probably should write that. Okay, so this is a mess, sorry. 1/2 times the base, which the original base was b, times the height, which is square root of 3 over 2b. So ending up with square root of 3 over 4b squared. Okay. tomorrow is pie day. Do we want to eat pie? I don't think I've somehow managed to not talk to your class about it somehow. Okay.